Okay, good day. Today we'll try to solve a simple problem in fluid statics, the very first problem in a reviewer. Now, here's the problem. If a depth of liquid of 1 meter causes a pressure of 7 kilopascal, what is the specific gravity of the liquid? So we are just here given nga na kay liquid nga ang iyahang depth 1 meter. Then at that level, the pressure that the liquid causes is 7 kilopascal. And we're just looking for specific gravity. So here, we'll just draw this first. Let's assume that, of course, the liquid may be um, a liquid inside a tank. Shall we say we have a rectangular tank here. And shall we say that the liquid level in the tank is has a depth of 1 meter. So we have that. Simple as that. Okay, that's 1 meter. And of course, that's the problem given 1 meter. And here we note that the pressure ang pressure daw dyan is 1 meter below or 1 meter below the surface, or pressure caused by this height of not water really, but an unknown liquid is 7 kilopascal. So we can have here a point here, which we call the pressure here is 7 kilopascal. Now we're looking for the specific gravity. By the way, when we say specific gravity, the symbol of this for some is Sg. It's simply equal to the density of that liquid to that of standard water, which is for SI unit, wala jud tay problema kay it will just be given by this raw of that liquid over raw of a standard water, raw of water. And when we say raw of water, it is the density of water when measured at 4 degrees Celsius, which is luckily good for us because the value of this is simply 1000 kilogram per cubic meter. So it will be really simple. So first, the approach here is we first solve for the density of the liquid. Then once we solve for raw liquid, then we can just directly solve for Sg. Now, how do we solve for the density of the liquid? Using the very common equation in fluid statics. We simply know that as we go deeper, the pressure simply increases by amount equal to the pressure increased by this value P equal to rho g h, where rho here stands for the density of the liquid, g is the acceleration due to gravity, and h is equal to the depth of the liquid. So as you go down, so you go deeper the liquid, then the pressure increases simply because of the level of liquid in there above you. So that's the idea. So simply in this case, we know pressure is 7 kilopascal, but we want standard SI unit, so we'll convert that to Pascal lang. So that will be 7,000 Pascal. So the standard SI unit for pressure. Raw, of course, in this case, we don't know raw of the liquid. That's what we're looking for. And G is known to be 9.81. And here, H, the depth is of course 1 meter. We can just simply drop the units if we know that we're solving this in terms of standard SI. By here, it implies that rho is equal to, so the answer is 713.56. So it will be 715.56. Of course, the unit of this will be the standard unit for density, which is kilogram per m cube. So this is what good in SI. As long as you put everything in standard units, then you'll expect that you'll get the answer. The unit of that will be standard also. So 715.56. So how do we're not looking really for raw, we're looking for the specific gravity. So we can say this is lighter than water, meaning density lower than water, and we expect that Sg for that. So here finally, so therefore, okay, so Sg, we'll put here therefore, para medyo social, therefore, specific gravity of the liquid is simply now equal to rho of the liquid, which is 715.56 divided by 1000 kilogram per m cube. So the density of water is simply equal to so let's say 0.72. Don't need to really put all the decimal places. Don't need to be that exact really. This is good enough. 0.72 is our answer. So just box it out. And therefore, that's the answer to our first problem.